Okay, this question is related to a previous optional question, and the optional question, certainly we're hoping you're looking at those, and if you can do them, that's great news. You can look back at this, you also just click on the link, and you get right back to that question on page 52, question number 4. And they want you to do this integration over here, and it doesn't look easy. For me to do this problem, it took some effort to think through it, right? The first thing I want to do is recognize that I do have a function, and that function I have is 2 to the x. And 2 to the x looks like this over here. It grows really rapidly, all right? And certainly, I hope you realize we're starting at, x to be 0, and this thing shoots off, and it really shoots up very quickly. And what do I know about it? I know there's a floor function over here. So really, I know I'm starting at this over here, and the first thing I'd get, I'd get something, and then all of a sudden it jumps up, all right? So remember, this is an exponential function. This point over here is 0, 1, and then someplace over here, it would shoot straight up there, all right? What does it hit? And then it hits 2, and then it maintains this for a while, and then it shoots up again, all right? And you're getting these little chunky little pictures over here, right? Time and time again, but it does shoot up really quickly. And we got to add them all together, all right? And that's a problem. Let me get my eraser out. Kind of, my preliminary thinking was just, where's this thing going? How do I compute those things? So what I really need to figure out, just like it did in that optional question, which was question 4, page 52, was when does this thing hit an integer, all right? That's when it starts to jump. So what I do is I set the function, I should say the argument of the floor function to some integer n. And again, I want to point out n is some integer. N is an integer greater than 0. So like 1, 2, blah, blah, blah. And I want to solve it. And it's not difficult to solve. And I'll get my eraser out and just remind you how you'd solve that for for x. You take the natural log of both sides. I think I'm going to do base 2, though, because it's a little easier for me to write it down. And so log base 2 of 2 to the x equals log base 2 of n. The x would come down, and you would get log base 2 of 2 equals log base 2 of n. And what do you get there? I mean, log base 2 of 2 is just 1, so x would equal, well, as stated, would just equal log base 2 of n, all right? So for the value n for that, log base 2 of n, if x is that number for any integer n greater than 0, we're going to get n as an integer, all right? Let me put out what I mean by that. If I were to write down 2 to the x, and I'm claiming x is equal to log base 2 n, this would just return n, which is what I want. When is this thing going to hit an integer? 1, 2, blah, 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 all right? So it's pretty, that's, I'm going to say understood there. I understand that. Then I start to think of myself as, what's the sequence of those numbers? And that's also relatively easy to write down. What do I write down? Log base 2, 1, log base 2 of 2, log base 2 of 3, so forth and so on. Again, remember, n is an integer, 1, 2, 3, and it goes on until you reach the number n, all right? So it does say start at n equals 1, and we did do that, all right? Then someone says, what's the base of each of those intervals? I get my eraser out, and we're going to talk about the base of it. Well, the first base, you have a base like this over here, and these are all going to be, little rectangles. Remember, the first one's pretty easy. It's just 0 to 1, but I want to write down what the logs. So what's this going to be? This guy over here is going to be log base 2 of 2, and this one over here is log base 2 of 1. What's the distance? Well, if you thought about it, it's upper minus lower. So what's the first distance going to be for that base? And we're just talking about the base over here. We're not talking the height. It's this. That's base 1. Let me get my eraser out. We'll talk about base number 2. Very simple pattern. What's base number 2? Well, looking at it, it's going to be this minus this. We keep going. Base 3. Log base 2 of 4 minus log base 3. We keep moving on and on and on all right? So base 1, base 2, base 3, we're eventually going to get to base n. And what's that going to be? Well, just looking at the pattern, it's a really kind of simple pattern. Log base 2, it's 1 more than the index n plus 1 minus log base 2 of n. All right? So I'm going to say the bases are pretty easy to deal with. The next thing I think about is the height of each of these guys over here. Remember, it keeps jumping from integer to integer. The heights are going to go from 1 to 2 to 3 to 4, and these are the heights. Let's see if we got those written down for you, and we do. All right? So what do I got over here? The heights. 1, 2, 3, up to n. So if you were to write down the areas of each separate rectangle, it's going to be, like for example, A1 is going to be H1 times B1. That's relatively simple. What's A2 going to be? Well, H2 times B2, so forth and so on, until you get to this one over here. And this is the computation, actually, of all those little rectangles, all right? So let me get my eraser out again, and I want to talk about, the next step up, which is adding these things together, all right? So adding them together, and I'll go through that with you, adding them all together. I want to write it down for you, though, and it's really not a bad thing to write down. So I'm going to add all these things together. And I want to point out, just writing it down, what are you going to get? Log base 2 of 2 minus log base 2 of 1. What's next going to be? 2 log base 2 of 3 minus 2 log base 2 of 2. What's the next one going to be? 3 log base 2 of 4 minus 3 log base 2 of 3. Yada, 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 yada. Let's go towards the end. What are you going to get? N log base 2 of n plus 1 minus n log base 2 of n. I like to go backwards on these guys over here as well. And what are you going to get? N minus 1 log base 2. Well, I go backwards. It's just n minus n minus 1 log base 2 of n minus 1. All right? So sometimes you're looking at this and you're wondering where it's going, and I'm wondering where it's going too, but I think I see a simple pattern. All right? I think I do. All right? And I want to point out the simple pattern I think I'm seeing. I'll write it down for you, and we'll go through it one step at a time. And let me do that for you. I'm seeing minus log base 2 of 1. That's right over here. And then I see this. And what would that give you? Minus 1 log base 2 of 2. Then I see this one. What's that going to give you? Minus log base 2 of 3. Now, granted, it's not written down, but I think you get the idea. You'd see one here, too. And I'm just going to say minus yada, 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 and I get somewhere. I'm going to say I get over here. By the way, this one here would have something over here to match up with it. Let's take a look at that one. You get n minus 1 minus n, which is just minus log base 2 of n. All right? Now, is there something left? And there is. I don't have this guy accounted for, so I'll just write it down. Plus n log base 2 of n plus 1. Well, I think I got it. And what do I have over here? Let's write it down. I have n log base 2 of n plus 1 minus, well, let's write it down, log base 2 of 1 plus log base 2 of 2 plus yada, 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 all up to log base 2 of n. Well, just using the rules of log, because I got to write down a simpler form of this. This is n log 2 n plus 1. minus log base 2. Well, if you look at this, and by the way, I really do encourage you to look at things, see what we're looking at too. If you're looking at this over here, it's just a factorial. That's all it is, just a factorial. And what factorial is it? N factorial. Right, I want to show you where that's written, right over here. We just completed the integration, by the way. And that's not bad, all right? So before I do that, though, I want to point out, I realize it's going to be very confusing. Why is this the case? Let's just look at some cases over here. Let's take n to be 0, all right? What would you get? Well, you get the integration from 0 to log base 2 of 1, which would be 0. So that would just collapse. Let me see if this is true, though, all right? If we're getting the same result, all right? This would collapse, by the way. What do I mean by that? We would just get 0. All right, let me see if my formula works out. I'll get my eraser out, and I'm going to make sure that n equals 0 gives me that 0. All right, let me get my pen out, eraser first. I'll erase this over here. And I want to see if that's true. All right, always test it out. So again, the right side worked out. When n equals 0, the right side is a 0. Let's look at the other side. What do you get? 0 log base 2 of 1 minus log base 2 of 0 factorial. Well, 0 factorial is 1. It works out beautifully. I get 0. All right? Let me get my eraser out. I'm going to try n equals 1 now. All right? Whoops. Sorry about that. And again, I know it's tough. Not going to do them all. Taking a few cases over here. Let's take n to be 1 now. All right? Now, granted, you have to understand what we're dealing with over here. This is going to be from 0 to log base 2 of 2, which is just the number 1. I'll put this over here. The floor, 2 to the x, dx. Well, I know that one too. It's this one. What is this going to be? It's 1 by 1. It should equal 1. By the way, these are not drawn to scale, but this is 1, 2, 3, 1, 2, 3, so forth and so on, all right? So we'll come back to this picture later. Let me erase this over here. Let me see if I get what they said I should get. N equals 1. And again, we checked out the left side. Let's do the right side, see what we come up with. Right, we're just checking our work, by the way. You get 1 log base 2, 1 plus 1, well, that's 2, minus log base 2 of 1. Again, n is 1. This is 0, this is 1, and 1 times 1 is 1. It's working out beautifully. We just finished the integration. Again, we checked a couple of them just to make sure that we've written down is correct, by the way. All right? Again, I want to emphasize, this caused me trouble to work through. It isn't like I get this in a matter of seconds. I also had to update things as I'm moving along, realizing the initial question I wrote down was too difficult. I kept rearranging it until I get something that worked out pretty nicely. But I have to write a problem that's doable, and I believe it's a doable problem. Just go back over the graph over here. What I did over here was I graphed in a couple different things for you. Let me go through that, and I'll write them down for you. This is y equals 2 to the x. This thing over here is y equals 2 to the x minus 1. I just dropped it down 1. And the other thing I did is I actually graphed out the floor function for this problem over here. I actually graphed out, whoops, sorry about that. I actually graphed out this thing over here. And the reason to do that, I just wanted to get an idea what it was looking like. I hope you realize by doing that, graphing that out, I have some idea what's happening over here, looking at it, all right? And again, you can go as far as you like with this over here. It's nice to have a graph, though, and I do want to indicate you should learn to use technology to do that. Thank you for paying attention.